All right, we're going to go ahead and talk about lesson 4.3, which actually covers quite a bit of information. It talks about prime numbers, prime factorization, all that good stuff. Okay, so first, let's go ahead and just talk about factors. Okay, this is a good place to start. And you probably are familiar with what a factor is, but let's start with 18. Okay, so 18, what are the factors of 18? Basically, those are what are the numbers that 18 is divisible by. Well, and the way I write factors is I make the pairs, okay? Well, right off the bat, I know that 18 is divisible by 1 and 18. 1 times 18 is 18. All right, and then I kind of work my way in. Okay, is 18 divisible by 2? Yeah. So 2 times what is 18? 9, okay? So 9 is also a factor. What about 3? Okay, is 18 divisible by 3? Yeah, so 3 is a factor. And 3 times what? 3 times 6. Okay, so we're kind of going in. Well, there's not a whole lot of numbers in between. Okay, is 18 divisible by 4? No. Is 18 divisible by 5? No. And then we're right at 6. Okay, so 18 has 6 factors. 1, 2, 3, 6, 9, and 18. All right, let's go ahead and do another number. Let's do 27. Okay, so right off the bat, first factor should be really obvious. 1 and 27. All right. Okay. Is 27 divisible by 2? Nope. Is it divisible by 3? Yes. Okay, so 3 times what is 27? 9. So we know that 9 is also a factor. Okay. Well, we only have a few spaces in here. 4, no. 5, no. 6, no. 7, no. And 8, no. Okay, so 27 only has 4 factors. 1, 3, 9, and 27. All right, so that's what a factor is. Okay, so now we're going to talk about what a prime number is. Okay, and I'm just going to list the first 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to go to 22, 11, 12. Okay, so we got the first 12 numbers. Okay, we're going to talk about prime numbers. Okay, so before I get into that, we're just going to write all the factors down for all these numbers. Shouldn't be too many because they're pretty small numbers. Okay, 1, well, 1 times 1 is the only thing. So 1 times 1 is, bam. Well, actually 1, we're not going to talk about 1. Okay, I'll tell you right now, 1 is not prime. It's not the other thing, which is composite. It's just kind of its own special number. Okay, so we'll actually start with 2. All right, so 2, well, right off the bat, you do 1 and 2, because 1 times 2 is 2, and there's nothing in between, so the only factors of 2 are 1 and 2. Okay, 3, well, that's the same thing. 1 times 3, and 3 is not divisible by 2, so the only factors of 3 are 1 in itself, 3. Okay, 4, well, we've got 1 and 4, right? But we also have 2, right? 2 times 2, so it has a third factor, which is 2. 5, we've got 1, and then 5, because 5 is not divisible by 2, 3, or 4, right? So it only has 1 in itself. 6, we've got 1 and 6, but we also have what? 2 and 3, right? All right. And then 7, we have 1 and 7, and it's not divisible by 2, 3, 4, 5, or 6. So the only factors of 7 are 1 in itself. Okay, 8, well, we've got 1 and 8, obviously. Do we have any others? Yeah, 8 is divisible by 2, so 2 times what is 4. Okay, so 8 has 4 factors, 1, 2, 4, and 8. 9. Let's always start with the obvious one, 1 times 9. Okay, is 9 divisible by anything between 1 and 9? Yeah, it's divisible by 3, right? And because it's 3 times 3, we only need to write the 3 once, right? We don't need 2 3s. All right, so 10, well, we'll write the obvious one down, 1 and 10. Okay, well, it's even, so we know it's divisible by 2. So 2 times what? 5. And that's it, right? It's not divisible by 3 or 4. Okay, 11, well, write the obvious one down, 11. Okay, 11, it's not divisible by 2, not divisible by 3, 4, 5, 6, 7, 8, or 9, 10. Okay, so just 1 and 11. 12, well, we've got 1 and 12. Well, it's even, so we know it's divisible by 2. 2 times what? 6. Okay, and I think it's also, yeah, it's divisible by 3, so 3 times what? 4. All right, so 12 actually has quite a few. All right, so numbers 2 through 12, we've listed all the factors. Now we're going to go ahead and talk about what a prime number is. Okay, a prime number is a number that is only divisible by itself in 1. So thinking about the factors, okay, the ones like 2 and 3, okay, their only factors were 1 in itself, 1 in itself. Look at 5, 1 in itself, 7, 1 in itself. It didn't have all these other little factors, okay? So if that's the case, then that number is a prime number. So 2 is prime, 3 is prime, 5 is prime, 7 is prime. Okay, let's look at this bottom row. Are there any prime numbers? Which one of these is only divisible by 1 in itself? Yeah, it's 11. 11 is prime. All right. Okay, so that's what a prime number is. Now, all these other numbers that aren't prime are called composite. Basically, that's the opposite of prime. If they're not prime, then they're composite. All right. And the one thing you'll notice is that most of the prime numbers are odd. And with the exception of 2, all prime numbers are going to be odd because if it's not odd, it's even, and therefore it's divisible by 2. Okay, so 2 is the only even prime number. Okay, every prime number beyond 2 is going to be an odd number. All right, so prime number. So let's go ahead. I'm just going to throw out a couple numbers. We're going to decide if it's prime or composite.
This is Doc. I'm so sorry. Do you know anything on flakes?
All right, 29. Okay, well, obviously 1 and 29 are factors. Well, 29, divisible by 2? Nope. Divisible by 3? This is where these divisibility rules are going to come in handy. Remember we talked about those a couple lessons ago? Okay, so we know it's not 2 because it's not even numbers. 3, well, 2 plus 9 is 11. Is 11 divisible by 3? No. Okay, 4, it would have to be an even number to be divisible by 4. 5, well, then it is 0, 5. Okay, 6, well, again, it'd probably have to be an even number. 7, well, 7's just one of those that you just have to kind of like, oh no, well, I know 4 times 7 is 28, so this is not divisible by 7. 8 would have to be an even number. 9, well, the same thing. Add the digits. 2 plus 9, 11 is 11. No. All right, and then at this point, we're pretty much figuring out, okay, no, there's no other number. So the only factors of 29 are 1 and 29. So therefore, 29 is prime. All right, let's do... Okay, 24. Well, right off the bat, I should know this is not a prime number. Why? I'm hoping you're saying because it's an even number. Yeah, because we know 24 is divisible by 2. 2 times 12. So it is not prime. Let's do 57. Okay, well, right off the bat, 1 and 57. Okay, let's see if there's any other ones. Well, now it's not divisible by 2 because it's an odd number. Let's do 3. Okay, I can work out 57 divided by 3, see if it works out, or I'm just going to do my little shortcut. 5 plus 7, 12. Is 12 divisible by 3? Yeah, it is. So we know it's divisible by 3. Okay, and right off the bat, if I'm just determining if this number is prime, since I've already figured out that 3 does divide evenly into that, I can stop because just adding the 3 to that makes it no longer, it is not a prime number, okay? So 57 is not prime. It's, what's the other word? If it's not prime, it is composite. Okay, so now we're going to the next part of the lesson, which is prime factorization. Okay, for some reason, I think this is really fun. I don't know. That's just me. So let's go to prime factorizations. You can think of prime numbers as kind of the basic ingredients of bigger numbers, okay? Prime numbers, you can't break them any further down, okay? They're like the basic components. So let's do prime factorization for 48. Okay, so right off the bat, 48, is it prime? No. Okay, it's even, it's not prime. Okay, so what we're going to do is we're going to kind of like in like an upside down tree, we're going to kind of branch off. Okay, what are two factors that go into 48? Like what number times what number, okay? If it's an even number, right off the bat, I automatically like, okay, well, I know 2 goes into it, so let's do 2, okay? So 2 times what is 48? Okay, so the 24 is going to go here, okay? So we've broken 48 into 2 times 24, okay? So let's look at these numbers. Are either of these numbers prime? The 2 is, right? Remember, 2 is the only even prime number. So if that's prime, I'm going to circle this, okay? I can't break this down into any, there's no other factors that go into that. It's done. Okay, 24. Can I break this down a little further? Are there factors that go into 24? Yeah, okay. So it is an even number, so I'm just going to go with 2. Okay, 2. 2 times what is 24? 12. Okay, so we're going to look at these numbers, 2 and 12. Are either of these prime? Well, I'm hoping you're saying, yeah, the 2 is. So I'm going to circle it. That branch is done. Okay, 12. Can I break this down further? Yes. Okay, still even. Okay, so I'm going to do 2 and 6. Okay, same thing here. Look at these branches. Are either of them prime? Yeah, the 2. The 2 is prime. Okay, can we break the 6 down further? Yeah. Okay, 2 and 3. All right, so we've got 2 and 3. Are both of those numbers prime? Yes. So we cannot go any further. All right, so this is called a factor tree, okay? It's kind of a weird looking tree, but we've broken the numbers down into their basic components. So we would write this if they're asking for the prime factorization. You first have to do a factor tree to figure that out. And then the prime factorization would be, look at the numbers that you circled, 2 times 2 times 2 times 2, okay, 1, 2, 3, 4, times 3, okay? That is the prime factorization of 48. And if I were to multiply 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 3, oh, looky there, I got 48. It's amazing. Okay, so when they ask for prime factorization, they want this, or you could do it if you're feeling really ambitious, we can use some exponents, okay? How could we use exponents to make this, just shorter? Okay, well, I have 4 2's, right? So let's write that as an exponent. 2 to the 1, 2, 3, 4th power times 3. Aren't these two things the same thing? And this is just a little bit more tidy. All right, let's do another one. Okay, let's do 52. Okay, so 52, we're going to do the factor tree first. So right off the bat, we're going to split it into 2. Okay, it's even, so let's put 1 with 2. Okay, 2 times what is 52? Anything. 26, right? All right, 26. Okay, are either of these numbers prime? Yeah, this one is, so we'll circle it. That branch is done. 26, okay, let's break that down further. Well, it's even, so let's do a 2 here. And 2 times what? 13. All right, well, we know the 2 is prime. Well, look at 13. Is 13 prime? Well, yeah, it's prime. So we're going to circle that, and we're done. Okay, so that's the factor tree. Okay, the prime factorization can be written as 2 times 2 times 13. Or how else could we rewrite this? Yeah, we could do 2 squared times 13. All right, so hope you have fun.